We have today Dr. Naser Valaei, and his topic is on an introduction to fuzzy methods for PhD students and early career researchers. I remember a few years ago, most of the webinars were about SEM, and now many of them are about fuzzy. Okay, and Dr. Naser is a senior lecturer in digital marketing at Liverpool Business School, Liverpool John Moores University, United Kingdom. Previously, he was a postdoc researcher in digital marketing at KEDGE. Am I right?
Yeah, Kedge Business School in France.
Kedge Business School in France, and a lecturer in marketing at Department of Marketing, Sunway University, Malaysia. His research has been published in several journals, such as Journal of Business Research. Oh, you have a paper in Journal of Business. I didn't know. Congratulations. Computers in Human Behavior, Information Technology and People, Technology Analysis and Strategy Management, Journal of Enterprise Information Management, Marketing Intelligence, okay, and many more.
You're reading everything.
Yeah, actually, it's a long list. So yeah, more information is on our website. He's an associate editor of the Asia Pacific Journal of Business Administration, which is indexed in Scopus, ESCI, and ABDC. It's an Emerald Journal, and sits at the editorial board of Journal of Promotion Management. He also serves as a reviewer to several high prestigious journals, such as Computers in Human Behavior. Not in Computers in Human Behavior, I feel they randomly reject, but later we need to talk about it. I have a paper there, but yeah, anyway. Journal
now
of
they're
Business.
getting so tough, these three
Yeah, they receive so many papers, so they just sit there to reject papers. Yeah. Journal of Business Research, and many more. Even tourism management. Okay. So again, thank you very much. And now we have, I think, 36 participants. So yep, stage is yours. Thank you very much.
Okay. Thank you, Dr. Said, and thank you everyone for participating in this webinar. So I'm gonna share my screen first and start right away. Just tell me that everything works here. So can you see my screen, Dr. Said? Yes?
Yes.
Okay.
Yeah,
so,
but it's not in the full screen. Yeah, it's good. Yeah, thank you. Perfect.
So I'm gonna minimize this. So, all right. Okay. Very good afternoon to all of you. So let me just see here. I can see myself. Okay. Sorry, I'm using Mac, so I have a little bit difficulty with these things. All right. So,
we see your conclusion slide.
Yes. Sorry. So let's just start from the beginning. Now you can see that, right?
Yes, thank you.
Okay. Hello, everyone. Today, I'm gonna give a very brief introduction about fuzzy methods, and I've been informed by Dr. Said that you have had another session. Your previous session was on fuzzy set QCA. So I try to delve into about the history of these fuzzy methods more, because I'm afraid that now you're familiar a little bit with this QCA and fsQCA. So I would like to talk about fuzzy set qualitative comparative analysis mainly. But in order to understand the logic behind this technique, it's noteworthy to touch on the backbone of this method, which comes from fuzzy logic. So I would like to provide an easy example in order to understand the notion of fuzzy logic. Just imagine old vacuums that had numbers 0 and 1 or 2 for turning on and off, or a light switch with on and off button, okay? Nowadays, the vacuums and the switch slice are not like the old times, but you can see the degree of light or the power of the vacuum with a measure. So this can also be extended to social science. This is a fuzzy logic view. This is a fuzzy logic thinking, okay? Several, okay, just, oops. Okay. Several studies mistakenly highlight the origins of qualitative comparative analysis and fuzzy set qualitative comparative analysis methods from the authors in 1980s, mainly the Regin 1987, but its backbone gets back to 1960s, where multi-criteria decision-making methods were proposed. So I'm gonna talk a little bit about one of the examples of the MCDM, which is fuzzy TOPSIS, and then explain about the QCA and fuzzy set QCA. Okay, as I mentioned about the origin of fuzzy QCA, which comes from the multi-criteria decision-making methods. Professor Lotfizadeh, which he still lives. He's a scientist and mathematician who lives in the United States. He proposed the fuzzy sets in 1965, and several fuzzy techniques were developed by Lotfizadeh's interpretation of fuzzy sets, majority of them in multi-criteria decision-making methods such as fuzzy TOPSIS, and TOPSIS stands for the technique for order of preference by a similarity to ideal solution, and other fuzzy methods such as fuzzy Mora, fuzzy Shannon entropy, fuzzy SAW, and others which have the roots in fuzzy logic. Okay, so this was the basis for the other fuzzy methods, the fuzzy sets which were proposed by Zadeh in 1965. And researchers Huang and Yun initially introduced the TOPSIS technique, which is a classic approach to solve the MCDM problems and provides a solution for a limited set of variables. Researchers indicate that fuzzy TOPSIS is mainly applied to rank the issues, and this technique is more efficient than the traditional TOPSIS technique in solving MCDM problems, in addressing the uncertainties in decision-making assessments, because it uses fuzzy normalized matrix. An example of this fuzzy TOPSIS technique is to rank a set of, let's say, 10 factors associated with online shopping behavior by 20 professors or 20 participants. Okay, so this method just make up a table of the fuzzy matrices in order to rank these factors. Other fuzzy approach, as I mentioned, the Mura and other things, they are more or less, they're doing the same thing. Okay, let's talk a little bit about the background of qualitative comparative analysis. It was introduced, as I said, by Charles Regin in 1987, which is dissimilar to multiple criteria decision-making methods and traditional methods such as multi-regression analysis and structural equation modeling. QCA is a Boolean analytic approach drawing on set theory, following the line of work by Prof. Zadeh. And the objective is to move beyond endless qualitative versus quantitative discussion in social sciences methods literature. So QCA is originally developed as somewhere between the case-oriented and variable-oriented methods. It somehow combines the principal attributes of case-oriented method, which is a qualitative approach, with the principal attributes of the variable-oriented method, which is a quantitative approach. And QCA is a asymmetric technique. Okay, just I hope that you know that the traditional approach such as multi-regression analysis and structural equation modeling, they are symmetric technique. They are mainly on the linear way of understanding, linear way of finding the results. But asymmetric technique is different. For instance, okay, as I said, in symmetric approach, the estimates of each hypothesized relationship are through the net effects. This means that it ignores the influence of other variable. Let's just give you an example. For example, the hypothesis relationship between job satisfaction and job performance. Okay, QCA argues that it is not it's not right to hypothesize such a relationship in this way, because there are a lot of factors that are influencing job satisfaction which are not counted here. Okay, or if the relationship gets rejected, we can argue that the relationship still exists, but in a lower degree. We should have a fuzzy view rather than just considering the net effect. Okay, so please remember the example of new vacuum and switch lights. Okay, just we are not talking about, okay, and bring it to the job satisfaction and job performance relationship. Okay, it's not a 0 and 1. There is a relationship or there is no relationship. It's a fuzzy way. Okay, you can say that if job satisfaction has some relationship with job performance, but to some degree. Okay, so this is a fuzzy point of view. And another thing in background of QCA is that it tries to provide causal explanations. For example, multi-regression analysis tests the extent to which the relationship between a causal statement, for example, a statement X involving one or more variables and an outcome variable Y, is symmetrical. In symmetrical relationships, low value of X associated with low value of Y. Or on the other hand, the high value of X associated with high value of Y. Okay. Furthermore, in symmetric approach, one combination of conditions result into high values of a dependent variable. But in reality, one combination of conditions results into high values in a dependent variable. Okay. So we can say that any combination of conditions has an asymmetrical relationship. This is in reality. So an asymmetric relationship with the outcome condition, and it's not a symmetrical relationship, okay? So we could argue that QCA is closer to reality because it's difficult to find a symmetrical relationship. Okay, the advantage of qualitative comparative analysis. Opposed to regression-based methods, one of the advantages of QCA is that its ability to work with a small number of cases, even between 10 and 20, providing other approaches in examining causal relationships. In addition, opposed to regression-based and multivariate methods, QCA does not draw conclusion based on single correct error. So, for example, a positive or negative relationship between two variables, but it provides different decisions, which are called solutions or configurations based on consistency and frequency thresholds, which later on I would be discussing about these things. Another point is that in social science research, several theories are ambiguous, at which they try to identify how causal conditions combine to provide results, and researchers make a number of possible causal constructs from a list of theoretical prospects related to the doubtful results but QCA makes it easier to apply set theoretic logic to occasions that differ in degree or level. So indeed, this is an advantage of fuzzy sets, because now it argues the way that a lot of researchers or PhD students combine different theories, okay? Okay, we talked a little bit about symmetric and asymmetric analysis. This table shows how different the symmetric and asymmetric methods are, and you can see the different terminologies that are used by these two type of methods. For instance, in a symmetric method, we have dependent variable. You can see the analogous terminology for asymmetric methods like QCA and fuzzy set QCA, which is an outcome condition, or independent variable in symmetric analysis, which is in antecedent or configurations in asymmetric. We have measurement items, which all of you are familiar with, but in asymmetric, we have calibration, okay, transformation of the values. In symmetric, we have net effects. We talked about net effects, and we just argued that it couldn't be right in reality. But in asymmetric point of view, we have causal recipes, solutions, or just simple recipes. And in symmetric analysis, you're familiar with the model drawing, which is with circles and ovals in structural equation modeling. But in asymmetric analysis, these drawings are with Venn diagram. And in symmetric methods, we have correlation matrix, but in asymmetric, we have truth tables. And interestingly, for coefficient of determination, R-square value in symmetric analysis, which a lot of researchers try to develop models with high R2 values. This is the analogous terminology for coverage in asymmetric point of view. And we have correlation in symmetric methods, which is called consistency or frequency in asymmetric view. And there are some Boolean signs, logical or, logical and logical not, which we don't have such terminologies for symmetric methods. Okay, another point that I would like to mention is that unlike correlation method, as I said, either earlier, okay, as I mentioned, the QCA is a set theoretic approach, and researchers started to question and doubt the traditional quantitative regression-based methods and SEM methods, as they work best with large sample sizes. In addition to support or reject the causal relationship, researchers conclude that their theoretical conclusions are mainly drawn by large sample size, which could be problematic, okay? And the traditional methods can also be argued in terms of testing the significance of a relationship based on the cutoff measures of p-value, let's say p-value less than 0.05 with 95% of the probability, and p-value less than 0.01 with 99% of probability. We don't have such thing in asymmetric methods. Okay, there are two types of QCA, CRIP sets QCA and fuzzy set QCA. The main difference between these approaches resource into the way the set membership is assigned. I will elaborate about this in next slide. Chris sets are binary values and they're not necessarily nominal. Fuzzy sets gets ordinal, interval, or ratio values, but our focus is on fuzzy set QCA. And fuzzy sets have several latent applications in the social science that need to be discovered. And the main purpose of the fuzzy set QCA is to estimate the causal combinations or configurations that result in full membership or high membership of an outcome condition, which is a dependent variable, which is the phenomenon that you are investigating. Okay, the first step in fuzzy set QCA is calibration. In order to use the values, we need to calibrate them. So calibration is the transformation of the values. For instance, if we have a 7-point Likert scale, we can transform it to the fuzzy forms. So in first column, you can see that Chris set has binary values, and fuzzy sets uses an interval of 0.0 and to 0. So from fully out to fully in, from the non-membership to full membership. Okay, and I forgot to mention about the set membership. Each cases has a value in a set, and set membership shows how high or low the value is. For instance, you can see different types of fuzzy set: 3 value, 5 value, 7 value, and so on. So let me just provide an example about the other types of fuzzy sets QCA. For instance, if there is a 5-point Likert scale from 1 for strongly disagree, 2 for disagree, and 3 for neutral, 4 for agree, and 5 for strongly agree, is the common usage of Likert scale. So these values are calibrated into fuzzy sets from 0 for strongly disagree, which is full non-membership, 0.25 for disagree, 0.5 for neutral, which is a crossover point, and 0.75 for agree, and 1 for strongly agree, which is the full membership. The intersection or the interpretation of the fuzzy sets for this calibration is that for the value of 1, it indicates that the strongly satisfied respondents are fully member of the satisfied respondents. And on the other hand, the 0 indicates that the strongly dissatisfied respondents are fully member of the satisfied respondents, or fully non-member of the satisfied respondents. So 0.75 indicates that respondents are satisfied with 75% and dissatisfied with 25%. Okay. And one of the things that I've read recently about calibrating is that it needs to be based on theory. So you cannot just haphazardly use the 5-point or 7-point fuzzy set. So it should be based on a theory, or you need to back it up. Okay. Okay, this table shows the verbal description of fuzzy set membership scores. Region indicates that, for example, values of 0.2 and 0.3 show that objects are weak members of the set. On the other hand, values of 0.8 and 0.9 show that the objects are strong members of the set, but not full membership. Okay, the next step in fuzzy sets is truth table, and it QCA follows the idea of complicated combinations, and an identical outcome may be resulted from different positive or negative combinations of conditions shown in truth tables. So truth table includes the reasonably feasible combinations or configurations of causal recipes or solutions and the outcome related to each combination. So in truth table, the solution or complex recipe gives a line for each path, which is a causal relationship to the outcome. In fuzzy set QCA, the purpose is to assess the causal recipes or solution that result in high membership. That's to say the value score to 1, which has the high membership in the outcome condition. And in choosing the causal recipes, researchers need to consider those solutions that have the highest consistency and coverage. Now we would talk about these two criteria, consistency and coverage. Coverage, as I said, which is identical to R squared, it assesses the empirical relevance of a consistent subset, and it measures the proportion of memberships in the outcome that is explained by the complete solution. And consistency, which is identical to correlation, assesses the degree to which a subset relation has been approximated. The consistency measure is the proportion of cases consistent with the outcome. I would provide you some examples with this coverage and consistency in the next slides. Okay, so this is one of the outcome conditions in truth table from my previous published research, which indicates that there are two pathways lead to improvisational creativity. The first is a high level of explorative learning strategy, which is fairly consistent with the value of 0.929 and describes a satisfactory number of cases with improvisational creativity coverage of 0.919. The second is high exploitative learning strategy, which has high level of consistency and coverage. The consistency is 0.91 and the coverage is 0.94. So overall, the solution has a high consistency of 0.89 and a satisfactory coverage of 0.965. Okay, sufficient and necessary conditions are the next steps in fuzzy set QCA. The logic behind the sufficiency indicates that when a condition is present, the outcome also exists. However, it is impossible that a condition exists without an outcome. So this means the sufficiency in fsQCA. And if a causal condition is capable of producing the outcome, but it's not the only condition available, then it is sufficient and not necessary. Later on, I will give you examples for necessity and sufficiency. So let's say if X goes to Y, X is sufficient and a necessary condition. Okay, there are three Boolean signs in fsQCA. So I just wanted to show you the sufficiency and necessity conditions, but prior to that, we should have some knowledge about the three Boolean signs which are used in fsQCA, the logical and, logical or, and logical not. And the logical and in the fsQCA refers to selecting the minimum score of the intersected set of a case. So it's this case, it is the set intersection, which is also referred as weakest link reasoning, according to Rieux and Reggie in 2009. And following the logic of Boolean algebra, the logical AND is shown in the outcome pathways of fsQCA as a multiplication sign. For instance, if there are two sets of A and B, the logical AND refers to the shared parts of these sets shown as A multiplied by B. In this case, if A is 0.17 and B is 0.3, then the shared part of these two sets is the minimum value of 0.17. So it is considered the weakest link. So it is one of the logical Boolean signs which are used in fsQCA. And the main application of this Boolean sign is combinations of conditions that shape sufficient condition for an outcome. And the next Boolean sign is the logical OR, as known as set union. So the logical AND was the okay. So this is opposite of the logical AND, which was multiplication. So this logical OR refers to the extent to which the two or more conditions have similar bases for an outcome. So the logical OR combines the sets of A and B. So it has a sign of plus or addition sign in fsQCA. If I want to give you an example, just the same sets, A and B, the combination of these two sets, A plus B, is the maximum value of 0.33. So the main application of this Boolean sign is finding the alternative pathways to an outcome condition. The last Boolean signs which are used in fuzzy set QCA is logical NOT, and which is called the set negation or absence of set, and it refers to the portion excluded from a set. And as you can see, the sign is something like NOT. I don't know what it is called, but if I want to give you an example, the NOT A is 1 minus 0.17, which is 0.83. So the main application of this Boolean sign is looking at how the absence or the opposite of a set works as a condition or outcome. Okay, now I would like to provide examples for, let's imagine this relationship. Explorative learning leads to improvisational creativity. So explorative learning is necessary and sufficient condition. In other words, if the existence of the condition is needed for the outcome to happen, albeit the presence doesn't inevitably indicate that outcome will actually happen. Okay, so the second condition, explorative learning multiplied by explorative learning goes to improvisational creativity. So this pathway indicates that explorative learning is necessary but not sufficient. And the third one, explorative learning is sufficient but not necessary. And you can see in the last one that explorative learning is neither sufficient and nor necessary. Okay. Okay. To conclude, we have mentioned about the application of the fuzzy sets. We have mentioned about the history and how it was began by researchers in 1965, mainly by Professor Zadeh, and there are several applications of this method in social science, and it is recommended that researchers also consider fuzzy set QCA or other fuzzy methods such as fuzzy TOPSIS or fuzzy Moro and other methods I've mentioned, rather than just sticking to the traditional methods of multivariate regression and structural regression modeling. And it is likely that hypotheses get rejected in traditional methods, but it is conditionally supported or fully supported in QCA and fuzzy set QCA methods. So therefore, mistakenly rejecting a hypothesis will result in a wrong decision making at all levels, and it would be catastrophic. And for PhD students, they need to make the best choices in what methods they are using based on the discipline that they are investigating. And researchers need to bear in mind that the correct steps and justifications for conducting fsQCA, as I mentioned, to follow the theory in order to using the right calibration. So it needs to be backed up by theory, and you can't just haphazardly choose 5-value calibration or 7-value calibration, as well as the truth table algorithm and the analysis of necessary and sufficient conditions. Okay, thank you very much. Now, I think I'm a little bit, I hope that I'm on time. So I take your questions now. So these are the references. I just stop share, and now I will take your questions